Hello physical science students, and welcome to our video that is all about properties of sound. In this video we're going to look at intensity and loudness, the decibel scale, pitch, and the Doppler effect. So let's take a look first at intensity. What is intensity? Well, when we're talking about sound, loudness depends on intensity. And amplitude is related to intensity. Remember that sound waves are longitudinal, and the amplitude is related to how close the particles of the medium are together in the compressions. When we have higher amplitude, these particles in the compression are closer together. So to produce a sound wave with greater amplitude, more energy must be transferred from the vibrating object to the medium. And when we have a higher amplitude for sound waves, that is related to its intensity. When you turn the volume up on your cell phone, you are actually pushing these compressions closer together, and you are hearing a louder sound. So we can define intensity by saying that it is the amount of energy that passes through a certain area in a specific amount of time. Sound intensity decreases with distance. You know that. Here's a little example. If we have a source of sound, a gong, say, for example, the intensity would be much higher closer to the source than further away. There's several reasons for that. The energy carried by the sound waves spreads out as the wave spreads out. Also, some of the wave's energy converts to other forms, such as thermal energy. And so by the time the energy or the sound wave is out here at this distance, the intensity is much lower. What is loudness? When we talk about the word loud, or is the sound loud or not, loudness is simply the human perception of sound volume. And of course, it depends on intensity. So let's take a look at how we can measure sound intensity. We use the decibel scale. And decibel is abbreviated lowercase d, capital B. And it's just the unit of sound intensity. You might be surprised to know that the very loudest sounds that your ears can hear are about 10 billion times more intense than the very softest sounds you can hear. Your ears handle a wide range of intensity, and so the decibel scale has been crafted in a way that can handle that. Every increase in 10 decibels on this scale represents a 10-fold increase in intensity. That means if you're looking at the difference between 30 decibels and 40 decibels, the 40 decibel sound is actually 10 times more intense than the 30 decibel sound. You might think, well, if I go from 30 decibels to 50 decibels, that's a 20 times increase? No, it's actually 10 times 10. When I go from 30 to 50 decibels, I am increasing by 10 times 10. 100 times the intensity of sound. If I go from 30 decibels to 100 decibels, that's actually 10 times 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 more intense. So that would be 10 million times more intense. 100 decibels is 10 million times more intense than 30 decibels in sound intensity. Sustained sounds above 90 decibels here can cause permanent hearing loss, and even very short, sudden sounds with intensity levels that are 120 decibels or higher can cause pain and even permanent hearing loss. So it's very important to protect your ears. So now let's take a look at the word pitch. When we are talking about sound, pitch is how high or low a sound seems to be. It is definitely related to the frequency of the sound waves. So remember that frequency measures how many wavelengths pass a particular point each second. And for our longitudinal wave, like sound, the frequency is the number of compressions or the number of rarefactions that pass by each second. So when we have a sound wave that has a very high frequency, and that reaches your ears, there are many compressions reaching your eardrums each second. And those waves cause your eardrums and all the other parts of your ears to vibrate more quickly than a sound wave with a low frequency. So your brain interprets those fast vibrations caused by high frequency waves as a sound with high pitch. So high frequency will be interpreted as high pitch. The notes on the right side of the piano have high pitch. Notes on the the left end of the keyboard have low pitch. They have lower frequency. And this brings us to our last idea, the Doppler effect. What is the Doppler effect? It is basically the change in a wave frequency because the wave source is moving relative to the observer, or the observer is moving relative to the wave source. Here, let me explain. Have you ever heard an ambulance or fire truck with a siren on it moving by you? If we think of the sound waves in terms of these rings here, and let's think of these rings as being the compression part of those sound waves. Here we have the compressions, and we'll think of the rarefactions as being this space in between. As this truck moves with its siren blaring, producing these sounds, you can see what is going to happen to the wavelengths of the waves. The compressions in front of the truck or the siren are going to be pushed closer together. They're going to be shifted to higher frequency and therefore a higher pitch. The waves behind the sound source, as it's moving this way, will then the compressions will become further apart, and that will result in lower frequency and lower pitch. This produces that very recognizable phenomenon that you've probably heard, a kind of a higher pitch as the sound source approaches you, and then it sounds different when the sound source is right in front of you as an observer, and then as it goes by, you hear this behind it. It's a different sound. It's actually a lower pitch. So this same phenomenon of the Doppler effect happens with other kinds of waves as well. For example, the frequency of electromagnetic waves changes if an observer and a wave source are moving relative to each other. If we have a source of light, and we're observing that source of light, let's say here from Earth, and that source is moving this direction away, it will give a red shift. We call that red shifted. If the source is moving towards us, we will see blue wavelengths, so it's called a blue shift. So this is very useful for astronomers when they try to measure the motion of stars and other objects in space. Also, the Doppler effect is a useful tool for police officers and radar guns, such as this one right here. It helps measure the speed of cars. If you're looking for some advanced ideas, read through here. When a jet travels faster than the speed of sound, the sound waves it produces trail behind it as a cone of pressure disturbances in the air. That cone might be heard as a loud sonic boom as the jet passes overhead. Who was the first person to travel faster than the speed of sound? When did this happen? Look into careers or workplaces that have dangerously high noise levels. Research that career. Find out what is done to protect the employee's hearing. Find out what government agency regulates workplace conditions. If you have other questions, please feel free to ask those, look into it, show me what you find, and I look forward to seeing you in class.